So with our new brief background in the history of survey research, we're going to talk about sampling. The prospect of survey research and sampling is to gather a sample of people that's small enough to interview and gather data on them and then make an inference from the sample to population. Presidential electoral politics, the topic du jour earlier. You can sample, ask the people, members of the sample, for whom they intend to vote, President Obama or challenger Governor Romney. Find the proportion of people, I spend a lot of time with proportions later on, find the proportion of people in the sample that report they intend to vote for Obama, and make an inference about the population from that. That's the game. Sampling basic approaches over here, and commentary, both historic relative to use in the past and currently, and also just general definitions about the nature of these things. First, remember the Literary Digest. The Literary Digest sample was a convenience sample. A convenience sample consists of units that are easy for, there's no math here. A convenience sample consists of units excuse me, that it's easy, where it's easy for the survey researcher to gather the data. You may have been stopped in a shopping mall by the survey researcher gathering gathering data from a convenience sample. The Literary Digest was a convenience sample because primarily they used lists that they could get, either motor vehicle list, their own list of their own subscribers. There's things that are convenient to them. There are all kinds of convenient samples out there today, and let's write this down. Convenient sample data are worthless. They're junk. They're no good. They tend to mislead. Convenient sampling efforts in survey research can be manipulated. It's just altogether really a bad idea. So let me give you some examples. So you go to Wendy's to get a cheeseburger, and right where you pay, there's these cards that you can pick one up and fill it out. How you're going to rate your experience there? How clean were the restrooms? And you don't ever do that. You just get your burger and go, or drive through and never see it. But some people actually do fill out the comment cards at Wendy's, or fill out the comment cards when you stay in a hotel. Increasingly, these things are migrating online. After you've stayed in a hotel, you get an email from them asking you to fill out a comment card. You buy something from Amazon, they ask you to fill out a comment card. These are convenience samples, and they can lead to, if you don't know what you're doing, you want to make an inference to some larger population of people who didn't eat at Wendy's, even to the population of people who did eat at Wendy's. These things are junk, and the reason should be clear to you. You don't ever fill those out, but you might, and ask yourself, under what circumstances might you fill out a comment card at Wendy's? They being the survey researcher, you being the convenient person to ask. You might, if you're really unhappy, you find a roach in your cheeseburger, you go to the restroom and it's completely filthy, and you get angry, and so people who fill out those kinds of things are angry, and so almost all the comments are negative. I think if I owned Wendy's and I looked at my comment cards, I would be really upset because you would have nothing but negative information. And the same as in those cards that are left in hotel rooms. Just gathering data from people who are convenient to you is generally a bad idea. When I worked for a gubernatorial campaign when I was young, I worked for a gubernatorial campaign, and one of the local television stations, local TV stations still do this, and it's bad practice, journalism majors and minors. Local TV station give sort of, in their first half hour, they give a number to call, and then you press 1 if you want to vote for this person too. So I think there's a Democratic primary in Alabama, and I think there are 4 people running, so you press 1 for this candidate. So they're going to report at the end of the hour the results of their poll. My candidate, who came in 4th out of 4, won that poll because we knew it was happening, and everybody was calling in multiple times. Convenience samples produce junk. They're bad ideas, and unfortunately, in a sense, combined with the quota sample, they've made a comeback. Today, the Gallup organization, academic groups gather survey data, begin with a great idea further down the line, the probability sample. They finish with a convenience sample, and they finish with a convenience sample because of the people they pick out to interview, probabilistically, only a tiny fraction respond. So response rates, when I was in the survey research game right after college, via telephone, response rates were extraordinarily high. This is the day when you called wired phones, right? And people answered and said hello. And then it was considered sort of bad etiquette to hang up on your, even a survey researcher. And universities did fantastically well with response rates. Today response rates are junk. Very difficult. When I go through the different modes of interviewing, in the next video, we'll have more comment on how today's scene looks more and more like 1936 every day. I mentioned Gallup and Roper. They're pioneers in both these games, certainly with the quota sample. By 1936, they all knew this, that you needed a sample that demographically looked like the population about which you wanted to make an inference. And so if there are important demographic divisions, let's say in politics, important demographic divisions, say race, gender, and we're going to do some work in this class on the gender gap in party politics in the United States. It turns out women are more favorable toward Democratic candidates than men are. You need to get these balances right in the sample relative to how they appear in the population. So if 53% of the voters in 2012 were going to be women, then you need 53% of women in your sample. That's the idea of the quota. And likewise, you need a representative group relative to race. You need a representative group relative to age. You can't. There's a big divide today in politics between the young and the old. And most of you are young. All of you probably are young, and you know this. You don't need me to explain to you that if I interview only older people and try to make an inference to the whole population, I'm going to get things badly wrong. So the idea of the quota sample is that you include in the sample key demographics relative to their appearance in the population. The problem with the quota sample, and it's true of today's efforts to mimic the old quota sample idea, the problem with it is you can't anticipate in advance what all of the important dimensions are. So you wait for gender, and you wait for race, and you wait for this, and you wait for that. But if it turns out something you didn't wait for is critically important, then your inference from sample to population is going to be bad because your quota sampling does not produce mathematically a representative sample. This thing does. This is how you get a probability sample. This is how you get a representative sample. The idea of the probability sample is most easily illustrated by a representative member of the probability sampling game. SRS stands for, write this down, simple random sample. A simple random sample is a probability sample. I'm going to define probability sample right now. Get ready to write. A probability sample is one drawn from a population where every unit has a known probability of being included into the sample. Once more, every unit in the population has a known probability of being included in the sample. When you have that, you have a probability sample. The simple random sample is the easy illustration because in the simple random sample, again the definition, in the simple random sample, the probability of a population unit making it into the sample, they're not just known, they're equal. A simple random sample is the case where every person in the population has an equal probability of being included in the sample at the end of the day. Beyond simple random sampling, there are complex designs. They can be, well, wow, an entire course can be taught on, and has been taught, and they are being taught, on sampling and design. Complex designs are often necessary as opposed to simple random samples because there are no lists that include everybody. So, for example, voting, registration lists are kept by the states and held quite privately. So you really can't write out a list and assign random numbers to everybody in the population, the voting age population in the United States. Is completely impractical, and many other simple random sample ideas would be impractical as well. And yet, as long as the probability of a unit in the population is known, statistics that we're going to use and learn and understand can be deployed and understood relative to the representativeness of the sample. So as a complex design, an example would be this. So I want a probability sample for every American voter. How do I begin? Well, I might begin using something called a cluster sample, and this is just an example. There are many designs. I might begin with a cluster sample, and the idea of the cluster sample is to gather people in groups of equal or known size and sample the groups first, and then discard those that weren't selected and sample inside the groups. 435 members of the United States House of Representatives come from 435 districts, the exceptions being those that are the single members from small states. Districts that are, in theory, contain the same number of people. So, in theory. Now, there's variation against that, but then in this process, it's the best you can do. So, an idea would take the 435 House districts and sample, let's say, 50 of those, and discard the rest, and go inside the House district and sample inside metropolitan statistical areas where you have a known numbers of individuals, and discard those that aren't selected, and keep going all the way down to the city block. And then keep going on down. From the city block, you choose at random a household. Inside a household, you choose at random a person. So designs can be that complex, and many of them, especially the academic studies, are in fact that complex. But the key issue here is the probability samples can be used reliably to say something about population values, and these two fail. Today, last comment on this, today, with response rates being what they are, and with, as we'll see, telephone interviewing still being the norm for most of the major polling organizations, today we have something less like this, as was the case when I got into survey research, and more like this. It's an amazing research challenge in a research area in which I'm actually interested. How do we deal today with the problem of low response rates being so low that the end result looks like a convenience sample? Because the only people who would answer the phone are odd by definition. And then that's corrected by applying weights that make it look like a quota sample, and we know that the people who come up with weights, they also, just like the people who came up with quotas of people to interview, they can't anticipate everything in advance that needs control. The probability sample is wonderful because you don't have to anticipate what needs to be controlled. Random selection. At some stage, every probability sample involves random selection of units from the population to be included in the sample. The process of choosing at random is blind to what all needs to be controlled, and so it controls for everything. And you could think about that. We're going to move now to the last video in the series, or maybe next to last. Talk about interviewing.